2 projects. In this video, we are going to explain about a project titled Fire Detection using yolov5. Fire Detection project using yolov5 and v6 deep learning algorithm frameworks have the safety and timely response to the fire incidents are critical. Our project aims to revolutionize the fire safety by employing the state-of-art object detection model to swiftly identify the fire instance and the images. With yolov5 speed and the yolov6 potential advancement, we strive to enhance the early detection, allowing for the rapid response and mitigation measures. By harnessing the power of artificial intelligence, we aim to empower the fire department, industries, and the individuals with a reliable and efficient tool to safeguard the life and protect the property from devastating impact of fires. The primary objective of our project is to develop a robust and real-time fire detection system. Leveraging the speed and accuracy of yolov5 and the potential advancement of yolov6, we aim to identify the fire instance in the images. And by integrating the cutting-edge object detection technique, our goal is to enhance the early fire detection and response, thus minimizing the risk of extensive damages and the saving lives. These are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. Importing the necessary Python libraries including NumPy, OpenCV, PyTorch to facilitate the data manipulation, image processing and the deep learning. And the second one is importing the dataset. Collecting a dataset containing of images to the labeled fire and non-fire region for training the yolov5 model. Ensure the dataset is well annotated, specifying the bounding box around the fire instance. And the next one is image scaling and processing. Pre-process the image by resizing them to the consistent size, ensuring the uniformity for the model training. And normalize the pixel value to bid them with a specific range for the better convergence during the training. And the next step is splitting into the training and the testing. Divide the pre-processed data set into the training and the testing set, ensuring the model is evaluated on the unseen data during the testing phase. The training set is used to train the yolov5 model, while the testing set is used to assess the model performance and the generalization. And the next step is building the model. yolov5 and v6 are the state-of-art deep learning framework for the object detection and real-time image analysis. yolov5 as a fifth iteration of YOLO series has gained the popularity for its simplicity and the performance. It introduced a lightweight architecture, enabling the real-time object detection on the various devices, including edge device and the embedded system. It employs a single-stage detector, directly predicting the bounding box and the class probability from the input image. And the second one is yolov6. It is an extension of v5 and offers the additional advancement in the term of accuracy and the features. A relatively new version would incorporate the improvement such as optimized architecture, loss function, data augmentation technique to push the boundary of the real-time object detection performance while maintaining a lightweight and efficient design. And the next step is training the model. Here we training the model using the training dataset, allowing it to learn the pattern and the features that distinguish the fire instance from non-fire region. And the next step is user gives the input. Create a web application using the Flask, a Python web framework to allow the users to input the image for the fire detection. And the next step is the given input is pre-processed for prediction. Pre-process the user provided input image to match the format used during the model training, including the image scaling and the normalization. And the next step is trained model is used for the prediction. Utilizing the pre-processed input image to make the prediction with the trained yolov5 or yolov6 model for the detection. The model will identify the fire instance and the bounding box and the image. And the last one is final outcome is displaying. Displaying the outcome of the fire detection process, highlighting the fire region in the input image and providing the information about the detected fire instance. And the next step is the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the images folder containing of the testing and the training set of various images within it, and the label folder containing of the labels that will be associated with the images, and the static folder containing of the folders like CSS, images, fonts, JavaScript, Bootstrap files within it. And the template folder containing of the HTML documents, it typically include home, index, notebook, sign-in and sign-up pages within it. And the test folder containing of the images within it that will be used for testing the purpose of the model, and the test cases too for the testing the performance of the model, and the train as used for training the data set, and the yolov5 folder containing of the images within it, and the app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains a combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then click on the enter button. And here we need to change the disk location to F because our code folder is present in fdisk. Then write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues within it. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it will redirect it to this page containing of the title and some information about it. And click on the sign up button. It will redirect it to the sign up page containing of some necessary details that need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the sign in page containing of username and password, and we need to fill those details to be logged in. And click on the login button. Here it will redirect it to this index file containing of the choose file button. It will redirect it to this folder containing of various images within it. I'm selecting one image and then click on the open button and then click on the upload button. Here the fire is detected in this frame with of bounding box and of the name within it. And I click on the back button and the refresh button. Here we can redirect to this folder file, and here click on the choose file button and select any one of the image and then click on the open button and then click on the upload button. Here in this photo the fire is detected in this bounding box. In this way we can detect the fire using the yolov5 and v6. And in conclusion, our project has proven to be significant advancement in the fire safety technology. The successful integration of these state-of-art models enable the real-time and accurate fire detection from the images and of video too. By enhancing the early detection and the response, our system holds the potential to mitigate the devastating impact of fire, saving lives and protecting the property. The efficiency and the precision of yolov5 and v6 empowered the fire departments, industries and the communities to proactively combat the fire hazards.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.